webinar for choosing the right abrasive for surface prep from US Minerals and Black Diamond Abrasives, as well as TCR. Just a couple of things to go through. I think everybody's microphones are already muted. If they're not, please mute them. You do not have to have your video on. This is, a presentation for you to see. If you have a question, please use the chat feature. You can either do it during the session and we'll try to keep track of it, or we are going to have a Q&A section at the end of this presentation. There should be a chat bubble near the top of your screen that you can click on and then type your message. And again, if you miss something, we'll be sending out the recorded video for your enjoyment later on. So to kick it off, I'm Aaron Holdreed, the National Sales Manager with US Minerals. I've been with US Minerals Black Diamond for about 4.5 years now. I manage the sales department, and at all of our sites, we have sites located in Wisconsin, Illinois, Kansas, Texas, and Louisiana, and our corporate office is based in Chicago area. And then I am remotely based in Detroit, Michigan. Keith is also joining us. If you want to introduce yourself, Keith.
Sure, I'm Keith Gabbard, and as it says, president of TCR Coatings, TCR Blast Abrasives. So we sell both coatings and abrasives. We're in St. Louis, Missouri, and we're a distributor, so we buy and resell. We sell the Black Diamond iron, among other abrasives as well. Got my start, it really came from coatings, from painting my way through high school and painting my way through in the evenings and weekends, and then painting my way through college. Got a BS in physics, and immediately kept on painting after that. Good move there, right? And painted my way for about 6 or 7 years. Painted commercial structures, light industrial and residential, and then started with Glidden in outside sales, painter maintenance, and then the last 8 years with Glidden, I was industrial maintenance manager for him in the Midwest. In '94, opened my business that was strictly coatings, industrial coatings for tanks and flooring and pipeline and asset protection coatings primarily. And as a result of the industry consolidation and companies buying out other paint companies, and we kept having to change the vendors that we're dealing with, we decided to take our same customers and go into the surface preparation end. That is, started selling abrasives probably about 2010, and been selling abrasives and coatings ever since. And it turned out to be a good move for us because it was the same customers, and since the coating system itself is dependent on the surface preparation, it kind of made sense to sort of integrate the two. And as I said, we're in St. Louis, Missouri, and we'll sell a lot either out of our warehouse here or direct from, like US Minerals has a facility in Houston. We sell a lot direct out of there. So that's about it.
All right, thank you, Keith.
Mm-hmm.
So we will start off here with surface preparation. All good coatings need a good surface to be prepped. And in order to do that, you need to blast it with some type of blasting media. And, a couple quotes here. The quality of surface prep is the single most important factor that impacts coating performance. They do need to be clean surfaces in order for the coatings to adhere properly. And you need to have the right material to prep the surface before coating. Another one from Bill Nelson. Today, with the cost of abrasives going up, it has been, as it has been over the past 10 years, people are looking at it as efficiency because the abrasive is a real cost associated with the blasting aspect. Not only the acquisition of the abrasive, but also the collection and disposal of the abrasive. Keith, I don't know if you have anything to say about this a little bit, since you get, into these jobs where all these things are involved.
Yeah, a comment I would have is that, coming from the coatings end of the business, we were used to being quite analytical with the marketing and sale of coatings. That is, we would try and break it down to square foot cost, so that if you had a gallon of paint and you're comparing it to somebody else's gallon of paint, and one was twice as much, the more expensive one still might be less expensive if it could be applied in, say, 2 coats versus 3. If it could be sprayed versus brush and rolled, if it could be applied at lower temperatures. And we would break it down in terms of square foot cost. Ultimately, you can't just look at the gallon cost, you have to look at the square foot cost. So the whole idea behind coatings is they will perform as long as they adhere to the surface. And so surface preparation and coatings systems are hand in hand. You can't do one without the other. And either one fails, the whole job fails. So surface preparation is critical, and degree of cleanliness, specification, making sure you're matching the profile height to the coating system, and using the right abrasive under the right conditions, and application in the same way. And we tried to approach our sales of abrasives in the same analytical fashion, which we'll talk about a little bit later. But if a system doesn't stick, you wasted a lot of money. And adhesion is based on surface preparation. So that would be my comment on that. They're you cannot separate one from the other.
Very good. Thank you, Keith.
Mm-hmm.
So now we get into the abrasive market. There are a lot of abrasives out on the market right now. The 5 main ones that we deal with on a regular basis are coal, garnet, nickel, glass, and copper. U.S. Minerals is processing coal and copper at this time, and we can source garnet and glass. For the purpose of this, we're going to concentrate mostly on copper, but wanted to get everybody to know what we're going to be talking about in comparison to other abrasives.
If I may, Aaron, one comment on that, on these abrasives, is that even within the same family of abrasives, they're not all created equal. For example, coal slag is derived from coal-fired power plants predominantly, and based on what type of coal they used in that plant will affect the properties of the coal slag abrasive. That is, if it's soft, say bituminous, low sulfur coal from the northern slopes, that doesn't make a very good abrasive because it's soft and dusty, and will have those kinds of qualities when you try to blast a surface. On the other hand, the anthracite, or the higher BTU, the harder coal, although higher generally in sulfur, is still a better abrasive, and it's harder. It has less dust characteristics, and so all coal slag is not created equal. Garnet can be either a hard rock, which is mined and angular and a little bit dusty, or it can be alluvial, which is brought off the beaches, and it's already rounded, so it's less dusty. Used a lot in water jet cutting operations and fabrications. And nickel slag is derived from nickel processes where nickel ore is taken, and the nickel slag that comes out of that process is cleaned and graded and washed and used as abrasive. It is a silicate as well as coal and copper. The glass is just crushed, recycled post-consumer glass. Think beer bottles, soda bottles, plate glass, that sort of thing. It's just recycled, crushed, graded, cleaned, washed, and sold, and has a lot of application in the slurry blasting market and some dry blasting. The copper is the one we sell predominantly, copper slag, derived from copper smelters. And you take copper ore, put it in a big vat, raise it up to, lava temperature where it turns into a liquid, something over 2000 degrees. And what floats to the top is an iron silicate. And that is pulled off of that lava and then cooled, crushed, graded, cleaned, and sold as an abrasive. So copper slag really has no copper in it. It's iron silicate. And, coal slag for that matter is a magnesium silicate, but it's the iron silicate that gives it its properties. It's for the most part, low dust, high performance, high production rate properties. And not all copper slags or coal slags are created equal. Some are much better than others. So there are nuances within each category and where their sweet spot is. But just because it says crushed glass doesn't mean it's the same as another manufacturer's crushed glass. So just want to point that out.
Thank you, Keith.
Mm-hmm.
So we get into factors when considering what type of abrasive you need to use for your project. Price. Anymore, this is a big factor. Prices can range. Usually the slags are on the lower end of the price range, and then glass and then garnet is usually typically the highest priced abrasive. For safety and environmental, all abrasives have some type of safety factor to be concerned about, and we will get into that a little bit later. The coal slag and copper slag from U.S. Minerals does meet the U.S. EPA and OSHA standards. Probably the big one right now is availability of material as well as transportation. As we all know, the trucking market is exploding every day. Prices are going up. We do, and I know Keith does as well, we work with several trucking companies and can get you the best price as possible. And we have made it a goal this year at U.S. Minerals to be able to keep our most popular sizes and packaging in stock at our plant. And then another is performance, which we will get into with some test data here in a minute, which I know Keith will talk about when we get there.
Aaron, if I can, just to go back to the transportation issue, we're in the middle of the country, of the U.S. here at St. Louis, and there are times when the freight cost on full truckloads, depending on the origination and the destination, where the freight cost is the same or more than the cost of the abrasive, and this is even more so nowadays, where the freight has really gone crazy. Sometimes we're paying double and even greater what we were 6 months ago for a full truckload on flatbeds. It's become a much more significant issue, and there's been delays in trucking, as everyone I'm sure is well known or knows, with the lack of drivers and sometimes equipment. It's been a challenge to get things on time, but all I can say is from the standpoint of abrasives, transportation, they're intimately linked together. You have to order early and allow for additional time and higher cost associated with transportation. And U.S. Minerals is seeing that too, even in the overseas where it comes in container load quantities overseas, that cost has doubled and gone beyond. Aaron probably know better than I, but all those costs have gone up significantly in the past 6-8 months.
Yes, they have. All right. Thank you, Keith.
Mhm.
So now we get into the case for copper and why we're pushing copper and the benefits to that type of slag. So as an overview, copper slag from U.S. Minerals meets SSPC AB1. Copper slag, at least what we market, is about 47% stronger. It has a much greater production rate from when you switch from coal slag to copper slag. It is a proven safe material. Our material is very low dust. And again, as we mentioned before, it does meet the OSHA and EPA standards. And we'll get into it later as well, but we do have a beneficial reuse program where you can purchase copper slag from U.S. Minerals. And in certain areas of the country, we are able to take the material and put it into a beneficial reuse. We do not bring it back and rescreen it and resell it. It actually goes into construction applications for a beneficial reuse. With that, it can save you money over landfilling, you know, in especially with large projects. Again, with copper, typically get the 20-20-20 factor, 20% less consumption than other mineral abrasives. It's 20% heavier, so you get a better blast with the copper slag, and it's 20% more cost effective. When we break down numbers here soon, you can see where you know, the cost benefit of copper comes into play. We move on to safety. As we said before, it does have the certifications along with it. We meet the OSHA safety standards. It's a low dust. The material is chemically inert. We meet the EPA standards. And as Keith said before, there's no copper in copper abrasives, only iron silicate. So that is a question that we get asked very often, if there is copper in there, and no, there is not. So Keith, I don't know if you have anything to add.
Well, other than I would point out that any blast or blasting any abrasive needs to have, you know, filtered air supplied hood and respirator like we see on the right of the screen there. At the minimum, all these abrasives are nuisance dusts. They're very fine. When they break down after being blasted, they break down in a very fine respirable size, you know, called PM10 or PM2, which in other words stays, it's so small, stays suspended in the air and you can breathe it in. So anybody that is blasting or close to a blasting operation that's going to be breathing this over time needs to have a air-fed filtered respirator, such as what is shown on the right there. That would be used regardless of what abrasive is used. So the safety, a lot of the safety factors that come into play in blasting is really up to the owner and the blaster to make sure they're equipped with all the PPM, appropriate PPM equipment.
Thank you. We're going to get into some videos here, and these field tests were done by TCR Abrasives, and I believe Keith, you were actually there monitoring these?
I was the camera guy, yes.
There we go. All right. So these are some short videos. We'll be replaying them, and Keith can speak to these videos as well.
If I may, before we start up on that, I ask that everyone watching pretend that you're the purchasing agent for your company and you've decided to test 4 different abrasives, and with the same equipment, with the same blaster on the same day, with the same substrate, and given the same specification, in other words, degree of cleanliness. In this case, was an SP6, all in the same steel. And you can see it's a rust grade, I'd call it B, A, maybe a little bit, but mostly rust grade B. In other words, tight rust bloom on that on the pipes. They're all the same. It's all done on the same pipes. It's all done with the same nozzle. It's all done with the same compressor and blast equipment. And so we try with this test to show the purchasing decision makers which one to would be the best choice. And there's going to be 4 videos. They're all very short, so we'll show them. Aaron's going to show them a couple times each. And I ask you to just pay attention to number 1, the speed of production, how quickly they remove the rust bloom and the mill scale. Number 2, the dust levels, and also what the substrate looks like. Are they all a minimum SP6 commercial blast? And then at the end of the 4 short videos, perhaps you can, in your mind, say, which one would I, as a decision maker, go with? I think you'll find out that it's not an easy choice to make just watching the production. And it's the reason why we did this test. And we'll talk a little bit more about it after the end of the videos, exactly how the tests were performed.
Real quick, Keith, there is a question that pertains, I think, to these videos. Have you adjusted the equipment to the abrasive used, or did you leave the settings the same for each material?
Very good question, Jaron, I believe your name is. And yeah, there were 2 different sizes of sieve sizes. So we had 3.5 turns on the micro valve for the 2 larger sized materials, and then 3 turns, turn it down a half a turn for the 2 finer materials. And that is extremely important when you're trying to maximize your production rate and minimize your consumption rate, is to have the abrasive metering valve adjusted precisely to the specific abrasive you're using. Generally, the finer the material, the smaller the opening that you want to have, because smaller, finer material tends to flow more like a fluid. The finer it is, the bigger the material, the less it flows, and therefore you have to have it more wide open. So we kept it at, and we'll show on the spreadsheet that we're going to show at the end of these videos, where we've identified the abrasive metering valve. Otherwise, the equipment was left exactly the same, with the same compressor, same hoses, same nozzle, same guy, blaster, and then same day on the same substrate. We tried to minimize all the variables that we could, or make them all the same.
All right, so we'll start this video here.
So this one this is actually a slag or material that comes from the steel making process. And this is a fine material, and we'll watch it again, but you can see it's as real time as we can make it. This is actually what the time that how rapid it was cutting. Okay, that was the fine A1 abrasive. The next video, Aaron, is we want to go to that. Okay, this is the garnet. This was a 80 grit garnet, alluvial. Maybe do that again. A lot of bounce back, as you can see. I was getting pelted with my camera phone as watching this, but you can see it's fast. It has a nice clean profile, very good material. And then the third material was the same abrasive as the first one, although this was an extra fine. This is where we turned it down to 3 turns versus 3.5 turns. Again, does a good job, even at those fewer turns. Now, on the micro valve, when you go from 3.5 to 3 turns, your consumption rate goes down, all things being equal. So theoretically, when you have the minimum turns on the micro valve, the abrasive metering valve, the material is going to last longer. The pot is going to last longer. Instead of 40 minutes of blast time on, say, a 600-pound pot, it might go 45, it might go 50 minutes. So that's the difference. What you don't want to do is turn it down so lean that you slow your production rate down. And there is a sweet spot where you have minimum consumption rate and maximum production rate, and that's what you want to that's what you want to adjust the micro valve to. And it's different for each abrasive. And the last one that we're going to see, Aaron, is this is the U.S. Minerals copper slag, the iron silicate. Okay. Again, if you're making a decision on which abrasive to use, you've seen they all work pretty well. I would consider all 4 of these to be high performance abrasives. That is, they're relatively low. A lot of the dust you're seeing, by the way, is the rust bloom that's being blasted off. Not all of that is abrasive. Some of it is abrasive that's being broken down and airborne. But a good part of that is the rust bloom as well. But I consider all 4 of these that we just saw to be high performance. In other words, low dust, high production rate, low consumption rate abrasives. So as a purchasing agent, having seen those videos, we really have no way of knowing which one's going to be the lowest cost per square foot. That's why I talked about coating systems and the analytics apply to them to get the lowest cost per square foot. So this next slide, if you will, Aaron, is how we, derived. Next one after this. Okay, so this is the industry standard formula to determine cost per square foot with abrasives, and the variables in here are the abrasive flow rate. In other words, how many tons per hour, the price, what's the cost per ton delivered. It also includes the cost of waste, of handling, of removal of the spent abrasive. And then you're looking at the production rate as well. So on this test, the ones that we just looked at, there were 4 different materials used. So if you look down at the bottom of the screen, the USM 80 iron 3060, the first one that's asterisk there. So we had 100 pounds of abrasive. It lasted 6 minutes and 10 seconds, and it gave us 85 square feet of SP6 cleaned metal on those pipes that you saw there. So 100 pounds, lasted 6 minutes, 10 seconds, 85. So we found out We know exactly how many pounds we use. We know the time that it took to blast that amount of material. And then you got the square footage. We just actually physically measured it. So the media A1 fine, which was actually the first video, those were 250-pound bags, and that lasted 6 minutes, 36 seconds, and actually had 103 square feet. The garnet was 110 pounds, 7 minutes, 41 seconds, 112 feet. And the extra fine was 100 pounds, 7 minutes, 59 seconds. So if you go back before we leave this slide, there's been some questions. The carbon steel, all 42-inch new pipe, is a number 6 nozzle, and we had 95 pounds of pressure on the nozzle. Those are all measured. Those are all known entities, known quantities. We tried to eliminate variables in order to reduce it down to the 3 variables: the weight, the amount of material used, the time it took to blast, and the square footage that it covered. And the 3 different medias were, as we mentioned, the last video was the iron, U.S. Minerals Iron 3060, the media A1 fine, which was probably about 50-60, 40-60 kind of blend, the garnet 80, and then the A2 extra fine, which is more like a 60 by 80. So if we go to the spreadsheet, now we have something quantitative based on that test that we can determine as decision makers on the abrasive, which one to go with. And as mentioned, there's 3.5 turns on the first 2, the iron and the fine media, and this is on the micro valve. And then we shut it down a 1/2 turn to make it leaner, 3 turns on the finer materials, the garnet 80, and then the extra fine in that steel slag material. So if we look at that first line, it's a little hard to see, but we took those numbers, the 50 pounds, the 100 pounds, 110 pounds, 100 pounds, we extrapolated that to tons. And so the abrasive flow rate, in other words, the consumption rate, we're at basically the U.S. Minerals Iron was at just under 1/2 ton, 970 pounds per hour, which, and then the fine media was a little bit less than that. Instead of 0.49, it was 0.46, or 900 and, sorry, I can't see it, 910 pounds per square foot. And then the one that used the least was actually the garnet at 0.43. Sorry, it was less than the other 2, but again, we turned it down a little bit, the micro valve, so it's going to have less media coming out. So it's at 0.43 tons, and the A1, the extra fine media, was at 0.38. So it was the least. And then the cost per ton, this is average cost based on, relatively current freight rates, $349 a ton versus the steel slag material was $598, garnet at $820. This is all per ton delivered, full truckload, and then $598 as well on the extra fine. And then given the abrasive cleaning rate, which is the second to the last line, 820 square feet per hour, 937, 874, 840. So those were extrapolated from the times and the amount of material that we have on there to give a cut rate per hour. Plug those all into the formula, and even though the U.S. Minerals Iron was a little bit slower and we used a little bit more, given the price per ton, it's the lowest cost per square foot. As you can see, 0.4 per square foot, 40 cents per square foot versus 46 for the fine, versus 58 for the garnet, versus 44 for the extra fine. So I know we went through that pretty quick, but that gives you a quantitative analysis on a field test in which we reduced it down to the best we could in the field. 3 variables: the amount of material used, the square footage that that amount of material covered, and then the time. You put all those together, given the assumption of $95 for waste handling a ton, $50 an hour for the labor rate, and equipment cost about $60 a ton, is just wear and tear. It's brace equipment is expensive to maintain. And given all those factors, and all those are the same, the only variables were the three that we talked about. And this is the numbers that we came up with. So this is the reason that we go with our main material that we sell is the U.S. Minerals iron, even though we get it out of Houston and bring it up to St. Louis. Freight rates used to be under 2,000, now they're closer to 3,000, but it's still the least expensive per square foot on the high performance materials that we sell here.
Well, that's a great way to look at it, Keith, and a very quantitative way to look at this.
If I may, too, Edith is asking on the profile. So the mill profile was anywhere from 1.5 mils to 2.5, almost 3 mils profile, just depending on the material. The finer materials, the ones that we had the 3 turns on, had the finer or the lower profiles. And again, the type and size of nozzle was, as mentioned before, a number 6 nozzle. And the type is a Venturi, standard Venturi, single Venturi nozzle. Relatively new, by the way. We made sure they had a relatively new nozzle. Didn't want it worn out.
All right. All right. We'll move on to the next section. Please, if there are any more questions, please type them in, and we'll try to answer them as soon as possible. So now we go into selecting the right abrasives. So one of the things that U.S. Minerals prides itself on is having the most gradations available in the marketplace at this point in time. We have a 1240, a 1630, a 2040, a 2850, a 3060, and then we have a superfine 4080. The 4080 has been used most recently as a material to blast stainless, and we're having a lot of luck with people are replacing garnet and using the 4080 copper to do the job that garnet used to do on stainless. And then the 2040 and the 2850, we're having a lot of success in the water tower, wastewater treatment facilities with those sizes. And then you move up to your coarser, your 1630 and 1240, which are your more heavy duty abrasives that are used in shipyards, oil derricks out in the water. They're used a lot. So we have all kinds of selections for you to choose from. We do have a guide on the Black Diamond website that can kind of guide you through the different mill profiles that these sizes will bring for you and help you choose.
Aaron, if I could also on that, I'd like to add, I think it's a great feature to have, the gradations that you have, the various gradations. Those are some fine cuts there, or differences, which is good. The reason that's important in a blasting operation is because we've done several tests in the same material. In fact, even in the iron, U.S. Minerals iron silicate, the copper slag, and on new steel, we compared let's say the 2040, which is a larger material, to the 3060, and we did the same exact test that we just looked at. Well, it turns out that the 3060 on new steel will cut faster with less material per square foot than the same material in the 2040. And the reason is, I kind of relate it to hunters going out and shooting birds, if you will. Pardon me on this analogy here, but if you're shooting birds, you're going to use bird shot, not double aught on your shotgun. And the reason is you have much better coverage with bird shot in a given area, your working area, than you will with the double aught. And the double aught is likely to miss altogether. Whereas the finer abrasive, if we can switch back, the finer abrasive is going to be more efficient at cleaning areas per unit of time. The proviso is that you have enough aggressiveness in that abrasive to remove. So if we to remove the either coating or rust that's on there. So if we get into a situation where we've got heavy epoxy or a lot of rust, then yeah, the 3060 is not going to work as well because it just doesn't have enough momentum, doesn't have enough energy, kinetic energy, being the smaller particle size. So you got to move up in size, and in doing so, you're going to impart more energy on each particle to the substrate to remove that epoxy, to remove that rust. Sometimes you even have to go with 60-30 or even 1240 if it's real heavy pack rust and a lot of coatings on there. But in any situation, regardless of what's on the substrate, it pays dividends to find the media that is the finest media that still has enough energy to remove whatever it is that you're removing. On new steel, we sell mostly 3060, if I can say that much. And that'll remove tight mill scale, rust grade A, rust grade B, all of them. So sizing is, once you pick an abrasive, pick the right size as well. That's the next step.
Thank you, Keith.
Mhm.
There was a question here. How is your experience with iron silicate on stainless and aluminum? Do you have any research data on that? We do have some, which I can send over to you, Dron. And there's also, as Bill just posted, we do have a lot of product resources on our the Black Diamond website that you can look at as well. Keith, I don't know if you have anything to add to the stainless and aluminum question.
The iron silicate works well on both. Again, you got to be careful with size, and a lot of it has to do with operator experience or expertise. You don't want to get too close, say on soft metal like aluminum, and you don't want to overblast stainless steel. You can harden that steel, but they do work. Sometimes with stainless, they're leaving it blasted and not coated, and some of the abrasives will sort of stain or leave a darker appearance that people may or may not like. So if it's being left by itself, just have to pay attention to the color, sort of the color that's left when it's finished blasting, which all abrasives leave a color, even if it's crushed glass or even the old silica, you just can't see it. Those are clears, but all of them leave a color to that substrate.
Okay, thank you, Keith.
Mm-hmm.
So as we talked about too, with the gradations in our 1240 and 1630 grades, again, it's for heavy duty. A lot of it's used in shipyards, and some is actually used in the wastewater treatment field as well. You can get about a 4 to 5 mil profile with that. It's a low dusting, fast blasting material. Our medium blends, which is the 2040 and 2850, we get into that 2 to 3 mil range that a lot of contractors are looking for. It's great on water towers and water tanks, great in the oil field business. And then again with the 2850, you can work on thinner gauge metals, like Keith said, new steel, and work in blast yards. And then our fine blends, the 3060 and 4080, you don't need to use sand, glass, or garnet. The 3060 and the 4080 work wonderfully on new steel, aluminum, stainless. It gives you 1 to 2.5 mil profile, and especially the 4080 can get you a a profile underneath that 1.0, kind of use it as a sweet blast for stainless and aluminum.
And for brush blast, if I may, brush blasting existing coating systems where the intent is to leave it intact, but degloss, remove contaminants, and then apply a coating system back over an intact coating system that perhaps has lost its gloss or it's, isolated failures here and there, but you want to overcoat those systems. So the 4080 would be an excellent choice for that, for sweep blasting, as you mentioned.
All right, so we'll move on to our last section here, the sustainability program. So U.S. Minerals has started a beneficial reuse program for copper slag, and depending on where you're working with it, we can do some coal slag into our BRU. So there's several factors involved in this. One is the economic benefit. Using our program, you can save money over landfill costs by using this program. And you can use our coal or copper slag, which is less costly to begin with. And so you get both sides of the coin. Environmentally, you avoid landfilling the material. It can be used in several applications, all in the construction industry. And you're also saving energy and money and our natural resources by using a slag over some of the other abrasives that are out on the market right now. Again, our materials are 100% recycled in approved applications. Like I said earlier in the presentation, they are not brought back to our plant to be rescreened and reused. We have several different ways of doing this. Some material will go back to our plant for stockpiling. Others will be taken directly to the end user. So, if you do see some material at our plant stockpiled, it is going to end up going to the end user. It's just how we transport it, whether it's by truck or by rail. So right now we have copper slag available at our plant in Galveston, Texas, as well as Harvey, Louisiana, which is right outside of New Orleans. And then, as Keith mentioned, he is our copper slag distributor in the Midwest and is located out of St. Louis. Our other plants on here, Roberts, Lacine, and Coffeen, is where our coal slag is located. And then our corporate headquarters is in Tinley Park, which is right outside of Chicago. Now it's time, if anybody has any questions, if you want to type them in the chat, we can hang out here for a little bit and wait to see if anything comes through.
Aaron, if it's okay, I'll respond to Jaron's second question here.
Sure.
Do you see in the U.S. also a trend towards finer profiles, thus finer abrasives? I wish I would see more of it. There's been a lot of studies, there's some recent studies that showed that normally on, say, epoxy on lining systems, 100% solids, thick film, 30, 40, 50 mils of coating going on a lining or some other application. In the past, they've wanted, 4, 5, 6 mil profile. And there's been some recent tests that were published in the JCP&L, Journal JPCNL, that said that the finer profiles, in other words, 1.5 mil, 2.5, 3 mil profile, perform just as well as the 4 to 5 mil profiles. And my suspicion is that there's sufficient anchor in there. I mean, there's two things that abrasives do. Number one is they remove abrasive blasting. It removes all contaminants, including mill scale rust, old coating, whatever might be on there. And second thing it does is provide a profile. What profile does is increases the surface area of contact of the coating to that substrate. So if you think of a smooth plate steel and you put a coating on it, it have in a square foot, let's just say, you have a square foot of contact. If you put a profile on there, you might have a foot and a half, 1.5 square feet of contact. And it also increases shear resistance, which all coatings are subjected to at some point, whether tank linings or flooring or whatever. And they're much more resistant to shear with given the profile. Having said that, again, there are studies that show that finer profiles perform just as well as the thicker profiles in some instances. So I don't see specifications changing to the finer profiles, but I think it's something that needs to be looked at, in my opinion.
Right. Thank you, Keith. There's another question here from Corey. In the last 6 months with higher shipping costs, does that cut into margins or is that passed through to customers 100%? So I'll take that. And Keith, if you have anything to add. So the way we price our material, Corey, is we have a per ton price for our actual material with packaging included. And then we price all of our shipping separately as a line item when we do quotes. So to answer your question, yes, that has been passed on to the customers, and it's like that. It's been like that since the beginning. So yes, the increases have gone to the customer. We are lucky enough, especially in the Gulf Coast, with our Texas and Louisiana plants, we do have our own fleet of trucks. So we can deliver with a flatbed or we can deliver with bulk pneumatics. Both are more local deliveries. We kind of need to get to a job site and back within 8 to 10 hours to stay, legal with the DOT. But that can cover a pretty wide range mileage wise. When we use outside trucks, we do have some good relationships with some brokers as well as some local trucking companies in each of our plant areas that can give us a lower cost without having to go through a broker.
I would echo that. We buy and resell, and depending on, normally we will, when somebody asks us for a quote, we'll get that current freight rate, and that goes into the to the bid process. So it is passed along. The problem becomes if we're bidding a job or a project today that's not going to happen for 2 months. Is that there's some variables there that can't be accommodated. And the cost might be higher at that point. So you just got to watch how far in the future you bid.
All right. Are there, I guess just to add a little more to that too, anymore the problem is we can bid these jobs with trucking, but you can't always get a truck. So, I mean, again, we've got some good relationships, but sometimes, trucks, there is a truck driver shortage. But again, we usually come up with something, but there are times where it is a little difficult to get a truck for the cost that you bid. So I'm sure all of us that deal with trucking have been through this within the past 6 to 9 months. It's frustrating, but again, with our network, we always get the load there on time.
I could take that. I don't know how much time we have left, but the gentleman asked on the recycling with copper slag versus say garnet. So we have tried recycling the copper slag. We'll get maybe a turn out of it before it gets to, it's more than coal slag. You'll get a, probably a full, darn near a full turn, maybe 1.5 turns before it gets too dusty. And whereas garnet might be 3 to 4 times, depending on how hard it's hit. We have sold copper slag for, I think someone asked before about using in slurry blasting. The answer is yes, we have. The thing to keep in mind is copper is black, whereas the glass, crushed glass, is sort of a sand looking appearance when it's left on the ground. So people sometimes don't like the color, and because they want to leave most of it on the ground, or a lot of it. And then, Aaron, you want that next one?
Yeah. So, Ori, with the pricing per ton, we don't really have any seasonal variations with abrasives. However, there is some variations in pricing according to location, and we see that more with our coal slag, since the coal slag is getting harder and harder to procure. We're having to go to different locations in the United States to bring it to our plants. So although there is a small increase in the price per ton when we get the raw material, the biggest factor in all this is the transportation to get it from the coal plant or stockpile to our plants. So some of them we truck the raw material in, some of them we bring in by rail, and those costs, do continue to go up. And to answer your question, well, let me go back to the copper slag now. Our copper slag in the Gulf Coast, we have been able to procure that material at a relatively low price, and we buy a very, very large amount at a time and bring it in. So right now we have enough copper slag at both of our locations to supply through the end of 2022 and into 2023. And other than some normal costs of doing business, there won't be any huge increases, for the copper slag.
Yeah, it's all location. So, I mean, we sell a lot of our businesses comes direct from a source, whether it's port city to anyway, the plant, wherever it's processed, the abrasive goes directly to the customer usually in full truckload quantities. And it's proximity. We're competitive as long as we're close because of the freight cost that's in there. And for us, the main driver in costs have been the freight. In terms of the last 10 years, if you will, freight costs have gone up and energy costs have gone up. So that's the main drivers, in my opinion, for the increase in cost of abrasives.
Another question here, decline in coal slag. How long do you expect coal slag to still be around in North America? That's a hard one to put a guesstimate to. They have closed a lot of the coal-fired power plants that actually produce the coal slag that is usable for blasting purposes. Again, it's hard to put an actual number to that, but I know that U.S. Minerals has at least another 5 years of supply, if not longer. Again, it's going to depend on after that on how quickly they close the rest of these coal-fired plants. As for copper slated to take the place of coal slag. There's other slags that are available. You know, for me to say that we're going to bring copper up to all of our other plants when we run out of coal, that's the big question. We don't know right this second if copper is going to take over coal, if some of the other slags are going to take over coal. It's kind of an unknown, but we do have a plan in place for the future to maintain our business at all of our plants.
If I would add that if the gentleman, Corey, and his customers love the coal slag, they'll probably like the copper slag as well. It's a definite improvement in performance, measurable, not huge, but measurable in terms of cut rate and dust levels, production rate, and consumption rate compared to coal slag.
I will type my email address in here. Keith, I don't know if you want to put yours in for additional questions regarding copper slag.
Sure.
You can also, just so everybody knows, we do have a Facebook page, Black Diamond Abrasives. We are on LinkedIn under US Minerals. And then we also have a YouTube page where we post several videos. And then you can go to our website as well, blackdiamondabrasives.com. We do have a lot of information on that website, as well as there's a form on there you can fill out to get more information about our recycle program. There's a contact us on there, and then there's also a 800 number you can call to reach customer service with any questions. This presentation is being recorded, so it will be emailed out, I believe, in the next couple of days to everyone that registered. So for people that had to leave early or were not able to get on, everybody that registered will get a link to this webinar. And thank you, Edith. We appreciate that you were able to get on. You're welcome, Corey.
Yeah, you're welcome.
So, all right, with that being said, again, thank you everyone for attending. We appreciate it, and we hope to do some more webinars in the future and hope to continue informed education on abrasives and changes in the marketplace.
Thank you.
All right, have a great day, everyone.